weekend. This is a short talk from Manisha about the advantages of NFS version 4.
And yeah, so I'll introduce myself. I'm Manisha Saini, and I've been working with Red Hat from last 1.5 years as a QE engineer with NFS Ganesha team, testing NFS Ganesha.
So Manisha, you have to speak up a little bit more so that the people can also hear you.
Microphone is not working.
So the microphone is only for the video.
Okay.
So as it is only the lightning talk, so I'll quickly go through the topics which are main, like what V3 lacks, and then what's improved in V4. Then we'll have a quick walkthrough on all the NFSV4 enhancement. Then we have a sum of difference between V3 and V4 in a tabular form, and then just a quick overview of what is NFS Ganesha and how we are moving forward with ClusterFS NFS Ganesha. So this is V3. So what's the problem with V3? So the main biggest problem with V3 is like it is a state test protocol, whereas V4 is a stateful. So stateless is kind of creates a problem in degradation of performance and locking issues. And then in NFSV3 we have firewall problems, like different services are floating on different ports. We don't have a dedicated port for some of the services like MountD, StartD, NLM, but we have few ports which have dedicated services like port mapper, which is 111, and NFS, which is 2049, but still it's kind of a drawback in firewall. Third is like we don't have any integration support with locking, so we use NLM layer for handling V3 with locking, and then we have only support with a POSIX ACL with NFSV3 Ganesha, and then at the end it only operates single operation per RPC, remote procedure call. So what's improved? It's a quick walkthrough on what NFSV4 has been improved. So first it's stateful, and then firewall has been improved with the dedicated port, which is 2049. Then we have a support of pseudo file system. Then there is a features like delegation and leasing over HA, and locking is also improved with as a part of protocol only. We don't have any separate layer for locking as we have in NFSV3, which is NLM. And then there is an integrated support of ACLs, which lacks in V3. And then there comes a performance improvement with parallel NFS 4.1 and multiple operations over compound RPC. So it's like one slide for each. So what is stateful? So with the stateful, we have two new operation, which is open and close calls, which leads client and server nodes like what is the condition of, they can easily communicate with client and server node. And guaranteed consistency in the sense in NFSV3, it keeps on writing from server from client to the server, irrespective knowing the writes have been pushed in the server backend or not. So the operations is like operation per 5 seconds. So all the operation will go in each 5 seconds. So it will kind of create network congestion and repetitive writing. But in NFSV4 this is improved, so it will not write the other operation before knowing that it has been committed in the backend. So and callback and recall function, so these terminologies are being basically used with delegation. So in the coming slide I will tell what is delegation. And in NFSV4 it also keeps the track of all the files which has been accessed by different clients at different times. And so every time it doesn't have to send any more information of the file again and again, and it eliminates the useless write through it, which I told you as a part of guaranteed consistency. And then it also improves the file locking via leasing over HA. So NFSV4 is firewall friendly. So you can see in NFSV3 we have different ports like port mapper, MountD, NFS, log, status, ACLs. We have different ports for different services. So if you can see, port mapper is fixed, which is always port 111, and NFS port is also kind of fixed, which is 2049. But the rest of the ports, these keep on changing. So the major drawback it will come when suppose the client is in firewall network, but the server is outside the network. So we don't know like which port the NLM and ACL services and NLM and mount services will be running. So it's kind of a drawback for NFSV3, whereas in NFSV4 all these are as a part of a single protocol, and it runs on a one dedicated port, which is 2049. So this is also one of the major benefit of NFSV4, which is a pseudo file system. So what is a pseudo file system? So pseudo file system is created on its own via NFSV4, and it's like I'll directly go through with an example. So suppose if the client has exported, if the server has exported the export fs local and export fs project NFSV4. So suppose if you mount the same root handle on NFSV3, so after mounting on NFSV3, the V3 client will have access to projects as well as NFSV4X also, because these are not like hidden. But in NFSV4, it is intelligent enough, the root file handle is intelligent enough to handle, it will only show the local and project NFSV4 directories as exported, but it will not show the other parts which are not being exported. If you want to show, you need to externally export these directories. So in pseudo file system, all these exports are act as a directory. We are under root file handle. So this is delegation in NFSV4. So NFSV4 support both client side and server side delegation. So delegation is a technique where the server provides the delegacy to the client, having permission to access to write something on the file without being sending each and every operation via backend in the server. So this is one of the major benefits. So delegation, it's like we have two kinds of delegation. Server can provide a read delegation as well as write delegation. So multiple client cannot be granted write delegation, because write delegation will, if two clients will have write delegation at the same time, it will create a inconsistency, and whereas in read delegation, multiple client can have read delegation. So who decide whether the delegation needs to be granted to a client or not? So it's only server who decides whether the delegation needs to be granted, and it depends upon the previous accessing of files, like previous pattern of a file being accessed by different clients. So suppose if the file is being frequently accessed by multiple clients, so it won't allow the delegation to those clients. And so here comes a consistency issues also. So when suppose a client 1 has taken a read delegation, and at the same time client 2 comes and it wants to take the write delegation. So in that case, the server will send a callback request to client 1 saying, return the file handle, return the delegation, because I need to grant it to client 2. So in that case, it will client, if suppose a client 1 has written something, it will just give all the commits to the server. It will commit everything, and then it will grant back the delegation to the server itself. But then the server will decide whether it needs to grant the delegation to other client or not. It's not guaranteed every time. So in delegation, all the operations are being copied from if the delegation is being provided by the client. So all the operations done via clients act as a local copy to the client. It will not send each and every operation to the server. So it kinds of improves the performance as well. So it's like quick walkthrough. It cut down the scope of revalidation requirement each time, because it has full permission from the server. The client can access anything if granted delegation, and it reduces the network traffic and therefore improves the performance on the client and the server, and have the access pattern of the file before providing delegation. It depends upon the access pattern, then only it provides delegation. And server may recall the delegation at any moment of time when other opens a file. It's like recall and callback operations. So what are the challenges? So delegation is majorly it runs on 2049 port only, but sometimes it may opt some other port depending upon the firewall issue. So it can create a problem while with delegation. So suppose if the server is unable to contact to the client for the delegation and it's not running on 2049 port, so server won't be able to grant the delegation to the client. And the other is, suppose if there are a mix match versions of clients running, suppose V3 clients and V4 clients, so the delegation technology will only be compatible with V4 clients and the other accessing the same file won't go through these delegation. And then there is a leasing over HA. So the problem with NFSV3 is it is a stateless protocol. So the client and servers are not aware of each other's state. So suppose if the client is rebooted, the server will still hold the lock, keep on holding the lock, and it will not allow the other client to take the lock. But in NFS, in the same case, if the but in NFSV4, if the client is rebooted, the server is very well aware the client has been rebooted. So it will keep a lock for some time, for some grace period, and then it will allow the other client to take the lock. But if the server is rebooted in NFSV4, so the server will put into a grace time for some time, and it will allow the client which was holding the lock earlier, it will give a chance to that client in the grace period to again take the lock, so that no other client can take the lock and it can again reclaim the lock. So this is what I explained. And more on locking. So it's the first thing only, it's integrated. There is no LLM kind of extra protocol running in NFSV4. And the client must maintain contact with NFS version 4 server to continue extending its open and lock leasing. So once the leasing is about to expire and the client needs to do some more operations, so the client is responsible for extending the leasing period. And NFS server, V4 server and client can, so this is the drawback in which the NLM in NFS V3 server and client cannot run LLM on the same client, like on the same node. It cannot act as a server and a client in NFS V3, whereas in NFS V4 it can be used as a single server and client. So ACL is one more benefit in NFSV4, whereas in NFSV3 it only supports the POSIX ACLs, and NFSV4 ACLs are much more richer than this POSIX ACL. So all the POSIX ACL can be mapped to NFSV4 ACL, but the vice versa is not same because it has many advantages in NFSV4 ACL which cannot be mapped to POSIX ACL. So we are currently, Stream users are currently working on fixing this. And in NFSV4 ACLs, the user and group information are stored in the form of a string, but not in numeric, where in POSIX ACL it is stored in numeric form. So in NFSV3, so compound RPC, so for each operation in NFSV3, it has to send small requests from client to server for each operation. Whereas in NFSV4, we can couple many requests in one call and send it to client. So it is kind of, it improves the performance. So you can see the lookup, open file and read data, all these requests have been sent in one RPC call. So this is the biggest benefit in performance in NFSV4, which is parallel NFS. So in parallel NFS, we have the metadata server and the data server. So metadata server is like keeping the track of on which node the file is present, and data server has the actual data. So suppose if the client needs to access any file, it will directly go to metadata server, and metadata server will point to the location of data server having the file, the node having the file. So then after that it can directly communicate in parallel with these parallel nodes at a time. So it's like parallel accessing from client to server. So it supports three types of provide three types of storage access protocol: file, block, and object. So file, block, and object. So these protocols are more related to client and data server communication. So based on it communicates as block, object, blocks or object or a file. So we have this PNFS feature in NFSV4, which is currently in tech preview feature. So this is just what all I have explained in the earlier slides. It's just the summary. It is stateless, it is stateful. Export are like NFSV3, all exports are mounted separately. But in NFSV4 we have the pseudo file system. So in NFSV3 we have NLM as a separate layer, whereas in NFS4 everything is in one single layer. And then in NFSV3 we have permanent locking. There we have the lease based locking, and RPC is like one operation per RPC. There we can have multiple operations, and the firewall issue. And at the end we have different layers, different protocols for different services in NFSV3. I'm running short of time, that's why I'm going through fast. So this is like you must have seen in earlier Supriti's presentation also, what is NFS Ganesha. It's just a user space address protocol compliant NFS server. So we have NFSV3 4.0 PNFS protocols running, and it uses the libgf API and FSL support to run the cluster server. So we have integrated HA with PCS and pacemaker currently, but in going forward we will be moving towards CTDB with NFS Ganesha, and it has the debus mechanism for exporting the volume. So suppose if one node is down, the other node will put all the nodes, other nodes will get to know, and it will put in grace period. And it supports a lot of file system like Gluster, Ceph, GPFS and Lusher. So this is the NFS Ganesha architecture, and this is what I explained. And this is the last slide, how we are heading with Gluster FS NFS Ganesha. So we have some improvements in coming releases, which is like reader chunking in NFS Ganesha 2.5. It's more related to improving find and RMs, and then we have X Reader Plus support in GF API, which is in cluster 3.13, and then we will be having a delegation support, which we are planning in NFS Ganesha 2.7 with cluster 4.0. Then we currently have pacemaker and corosync as a HA, so in coming release we might be moving in CTDB, and then we are also planning for asynchronous IO for NFS Ganesha 2.4 release with cluster 4.x. So these are the reference. You can contact anytime with this mail and IRC contact. Thanks. Any questions?
Yes, thank you, Manisha.
Yeah, thanks.
I'll open the door. If you have questions, ask them to Manisha. I'll say one to leave. People travel back to wherever they come from.